Hello, we are students from Intro to Engineering 170 at UW-Madison tasked with creating a portable water sample incubator that can hold 50 petrofilm samples for Engineers Without Borders Guatemala. By creating this incubator, we will be helping the engineers using it for easier testing and the people of Guatemala who will benefit from knowing that water is free from harmful coliforms. The previous way that UW-EWB was heating the samples was inconvenient, as they were just taping the samples to a member's body. We wanted to create a design that would be portable and make the sampling process easier.
Design 1 is the backpack incubator. The backpack incubator was one of our first ideas, and it includes an incubator that is attached to backpack straps for ease of carrying. There is a door on the back that opens to a storage compartment with slots. There is a heating coil on the sides and a column in the middle that divides it in two so the films are separated. There's also a battery compartment and Arduino in the bottom right corner. We decided against this idea because it was going to be too difficult to fabricate and the cost was out of our budget.
Design 2 is the cooler incubator, and it is the one we ended up going with. This design is a more simple box design created with inspiration from a standard cooler. This design is able to be fitted in a backpack, which is why we went with it. There are 4 sections with petrofilms. There are heating pads on the sides. It is the same heating system as the backpack incubator. The current design is made of polycarbonate and has a lid on the top cut out, with a foam seal on the top.
Design 3 is the vest incubator, which is modeled after the previous method of incubating the samples. We decided not to go with this design because it would be over our budget of $300. This vest has a zipper up the center so it could be worn and zipped up snugly. This design would be beneficial to the wearer because it distributes the weight to the front as well as on the back. There would also be an incubator on the back, which would be similar to our cooler design. There would be an additional padding on the back for the comfort of the wearer.
This is Sadie and Abby filing down the door so the rubber seal can fit in between the door piece and the rest of the lid. The first image on the screen is showing the foam on the inside being cut out for our slotting system. The second image is showing the soldering technique to adhere the pieces together. The third shows the beginning of the creation of the box shell using the polycarbonate material. Lastly, there is an image of the box including the foam and electrical components. This video shows the testing for the electrical component. When just the blue light is on, the thermistor is reading less than 34 degrees Celsius and is on at 100%. When the blue and yellow lights are on, it is within our range of 34 to 36 degrees Celsius and is powering at 66%. When there are no lights on, the temperature is above 36 degrees Celsius and the power is off. This shows how the incubator can fit inside a backpack. This shows how easy the incubator is to use, showcasing the ease of placing a sample in, as well as taking a sample out of the incubator.